Hi, this is Dr. Bharadwaj. We are going to now discuss about the weight of an observation. What is an observation? Any value you got in your data set is an observation. How important it is known as weight of an observation. So why we need to know the weight of observation or importance of that particular observation or the importance of that data in a data set is it determines what type of a statistical inferential method you have to use, or it determines what type of statistical descriptive measure you have to use. Depending on the weight, there are different formulas you have to use. There are for example, just take mean. There are different types of mean, right? Arithmetic mean, harmonic mean, geometric mean, weighted mean. What type of formula you have to use to measure the mean also depends on the weight of the observation, or what type of statistical inferential method you have to use depends on the weight of an observation. There are different values in a data set, but each value have different weight or different importance. In some cases everything is same. Now we will look into the importance of weights of observation. Weight of observation, the relative importance or contribution assigned to each data value in a data set. Okay, you have a data set. In a data set, all the values are not equal. Some values has to be given more importance, some values has to be given less importance, some are more important, some have more weightage, some have less weightage. So based on that we will classify the data. Okay, the data we have got, based on the importance we can classify the data into two. One is equal or fixed weights, or unequal or varied weights. Okay, there are two types. Whether in a data set all the values have the equal importance, or different values have different importance. That is going to determine what type of formula we have to use, whether for a statistical inferential method or statistical descriptive measure. Now we will look deeply into it. Based on the weight of an observation, there are two varieties. One is equal weights or fixed weights. Next one is unequal weights or varied weights. There are two types. Now we will look into equal or fixed weight. The name itself says all the values in a given data set are equally important. Each observation is given same level of importance in the calculation. Okay. Best example, for a patient in an experiment. There is a patient. We are doing some experiment on the patient. The heart rate is 72 beats per minute, measured when completing 1000 beats at rest. When the patient is at rest, we have calculated heart rate. How many beats we have considered? 1000 beats. We have measured 1000 beats and came up with this value. I have measured 1000 beats. In that 1000 beats, the heart rate is showing 72 when the patient is at rest. Okay, resting heart rate 72 per minute is the heart rate, and I have measured for 1000 beats. I have counted 1000 beats, and the 1000 beats are beating at the rate of 72 beats per minute. Okay, next one is heart rate is 108 beats per minute, measured while completing 1000 beats under stress. When what we do next, same patient, we will put him under stress and measure 1000 beats. When we measure 1000 beats when the patient is under stress, the heart rate has become 108. Okay, and the same thing, we put the patient to exercise and we measure 1000 beats and the heart rate is 144 beats per minute. Here you can see the heart rate is varying. It is 72 when he is at rest, it is 108 when he is under stress, it is 144 when he is doing exercise. But how many beats we have measured? For 1000 beats, we have counted 1000 beats like this. That's the reason we say all these values are equally important. Okay, the weightage of these values or the important level of all the values 72, 108, 144 are given equal importance because we have measured for 1000 beats for all of them. It is known as fixed quantity observation for 1000 beats. Okay, in all the cases we have observed only for 1000 beats. That's the reason in the calculation we have to consider everything is equal, and accordingly we have to select a formula. Next one is unequal or varied weights. The observations are given different levels of importance in the calculation. In each calculation each value has to be given different importance. For example, for a patient in an experiment, the heart rate is 72 beats per minute measured while completing 500 beats. First we have taken the patient and we have measured the heart rate at rest, and the heart rate is 72, but for how many beats? It is only for 500 beats. We have measured only for 500 beats. When the heart rate is 108, when the patient is under stress, we have made the patient undergo stress and we have measured the heart rate. The heart rate is 108, but for how many beats we have measured? That is 750 beats. Like this we have counted 750 beats and we have divided it with the time. It gives 108 beats per minute. In the same experiment, we have made the patient to exercise and we have counted 1000 beats. And for 1000 beats, what is the heart rate? It is 144 beats per minute. Here it is 72, 108, 144, but it is for 500, 750 and 1000 beats. It means for each value, 72, we have to give low importance. For 108, we have to give medium importance. For 144, we have to give more weight in the calculation. So it is varied in quantity, observed for 500, 750 or 1000 beats during exercise. That's the reason, depending on the weight of the value, we have to give importance. Based on the weight of the value, okay, we will select a formula. Maybe it can be a statistical descriptive measure. Best example would be mean, median and mode, or it can be statistical inferential method. Based on this weight, we have to select the different formula or different method. Thank you.